When we say rapid revision, just quickly, matter is classified as pure and mixture. Pure is means there is only one substance. One substance can be element, can be a compound, but if it is element, it will be element only. For example, if it is aluminum, there will be aluminum, aluminum, aluminum only. If it is calcium carbonate, it will be calcium carbonate only, nothing else. So it will be pure. It means when we say mixtures, mixtures have impurity or more than one component. So if I say I have one compound, okay, say zinc, but there are few lead components also. So it's a mixture. That's the simple definition. Pure substance because everywhere you will get aluminum, 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 or calcium carbonate, calcium carbonate. It means these will be homogeneous. Everywhere you will get same thing, and that is the definition of homogeneity. Homogeneous means everywhere it will have same composition, no different composition. But mixtures will be heterogeneous because somewhere you can get zinc, somewhere you can get lead. Suppose you have sand and uh, copper mixed into it. Somewhere you can have sand, somewhere you can have copper. That's the mixture. So pure substance, homogeneous. They can have element or compound, but one at a time. Mixtures, two, and heterogeneous. Homogeneous means uniform composition, everywhere same. Heterogeneous means they have different composition at different places. Then relationship between Fahrenheit and degree Celsius. Quite a few times I have seen students doing mistake here. So there is something you can remember in the it is something Phulan. You have heard Phulan Devi, right? Then Phulan Ne Param.
Sir,
Now you can remember it. Just a second. Okay. So F Phulan Ne 9 Param P 5 C Chand की 32वीं चोट. Why I'm telling you so? Because many a times I have seen that students have written negative here, or they have written degree Celsius here and Fahrenheit here, 9 by 5 here, which is wrong. So you can remember it like this. Yes, you were saying something, Samad, or someone else.
yes, sir. I was asking, sir, that there's one more formula regarding to the temperature that is F minus 32 upon 1.8. I think that is the formula. So why is so? Sometimes I thought that is also a relationship. Is it true?
Tell me the formula again.
So it's something like F minus 32 upon 1.8. I think that is the formula.
Yes, that is in terms of decimal. Okay. You
Okay,
can
sir.
use that, but that is not the standard formula. So your teacher might cancel that. That that is
Okay.
not written in the book. Okay. So this is what you will use the formula, standard formula. Okay. And Kelvin and degree Celsius, it is very simple one. You just add 273 or specifically 273.15 to get Kelvin. One important point is that Fahrenheit and Celsius are represented in degrees. So you will say degree Fahrenheit, degree Celsius. But Kelvin, you will not write degree Kelvin. Whenever temperature is written in Kelvin, you will just say 373 Kelvin. You will not say 373 degree Kelvin. Then scientific notation is of this form where n can be from 1 to 10 but less than 10, cannot be 10. If it is 10, obviously you will convert this into 1.0 into 10 to the power 1. So it cannot be 10. It cannot have 2 digits before the decimal. I am talking about standard notation. Although in the answers you are allowed to write it something 12.53 into 10 to the power 5. It's not wrong. I'm not saying that it is wrong or right. I'm saying what is standard scientific notation. If we are talking about scientific notation, it is a standard form. This is not a standard. Not being the not standard form, not being the standard form does not mean that it is wrong. It is not wrong. It is just not a standard form. A standard form will be 1.253 into 10 to the power 6. Same. Then a lot of students are confused in precision and accuracy. When we say precision, precision is only related to the measurements. We do not talk about what is actual value. So suppose if we say we have 5 kilograms of rice and we measure it, and the measurements of 5 kilogram of rice, we got first measurement as 4.90 kilogram, then we got 4.95, we got 5.05. When we say precision, precision is only between these or amongst these readings. Measurements, 5 kg is actual value. Actually, it is 5 kilograms, but measurements are 4.90, 4.95, 5.05. So precision will tell us how close these values are, how close the measurements are to one another. Means within themselves how close they are. So if I say another person measured it and he got the values 4.91, 4.89, 4.90. So these values are very close to one another. 4.89, 4.90, very close. 4.91, 4.90, very close. So it means these have high precision. But if I talk about accuracy, accuracy is how close it to the actual value. It means 4.91 is not as accurate as 5.05 is. Between 5 and 5.05, the difference is only 0.05. However, between 5 and 4.91, the difference is 0.09. So the difference between actual value and measured value is greater. So accuracy is difference between the actual value, which is also known as true value, and the measurement. Accuracy is the agreement of particular value of the to the true value of the result. So with an example, I'll just show it. It is example from NCERT. This says student A measured something, B measured something, and C measured something. Student A, and remember the true value is 2. 2. True value in this case, true value means actual value. Is 2 grams. Student A measured 1.95, 1.93. 1.95 is far away from 2 gram, 1.93 is far away from 2 gram. So both of these are not accurate. These are not accurate because these are far away from 2. Why I'm saying so? Because I have the readings of C also. If I consider C, it is very close to 2, 1.99 also very close to 2. So it means these readings are accurate. And at the same time, these readings are close to each other also. 2.01 and 1.99, these are very close to each other, not much difference. If you see others have, for example, this one, B, has huge difference in the reading. So it is precise also. Now come back again to A. 1.95, 1.93, these are far away from 2 grams. It means these are not accurate. Okay. But if you see, these are close to each other. So somewhat they are precise. So precision does not mean that they are accurate. Precision just measures how close the readings are. So if you have reading, for example, for 2 grams, you have reading 1.5 and 1.51, 1.52. These readings are far away from accuracy because the actual value is 2, but still these are precise. Why these are precise? Because these are close to each other. So if I consider these ones, these are not accurate, not precise, too much precise. Okay. There is a reason. I'll tell you why I'm calling this one not precise and I'm calling this one precise also. Although the difference is 0.02 in both. Okay. This one, if you consider, these ones are neither precise nor accurate. Both are far away from the true value and both are far away from each other also. So from these are far away from true value, these are not accurate. These are not close to each other, that's why not precise. Is there any confusion? Let me know. This one is not accurate because these are not close to 2, but somewhat precise. Why precise? Because these are close to each other. These ones neither accurate because these are far away from true value, nor precise because these are not close to each other. These two are accurate as well as precise. Any confusion in understanding, let me know. In a few cases, you will consider average also. Now, why I said that this is exactly precise, and in this case, I said this is somewhat precise. Because if you consider the average still, if you see, is far away from the true value. Here it is exactly true value. So although it is not related to precision, is not related to accuracy, but if average is somewhere related to close the accuracy, then we say it is rather, it makes more sense that it is accurate as well as precise. So I hope you understand at least this part. And if there
Sir,
is any confusion, let me know. Yes.
sir, precise also means near to the true value.
No, precise does not mean near to true value. Precise means only near to each other. The measurement should be close to each other.
Okay, sir.
Accuracy means only true. Now, significant figures, there are certain rules. Significant figures means we have some meaningful digits which are certain, and one last digit is uncertain. The last digit only is uncertain. Otherwise, all the digits are certain. There are rules, and I hope you remember. If still there is any problem, just stop me and get clarification there. All non-zero digits are always significant. Zeros before non-zero digits or before decimal are not significant. So zeros, if they are before decimal or before any digit. So you can say if zeros are not, or zeros do not have any non-zero digit towards left, these will not be considered. So these zero non-significant, these zero non-significant. Why? Because you don't have any significant digit here. For example, 5, 2, that's why. If these are towards left, most places never considered in significant figures. Zeros between two non-zero digits are always significant. So if I have written 2005, all four are significant. These two are significant, and these two zeros are in between two significant figures, so that's why these become significant. All are significant. This one is the important point. Students make mistake here. Zeros after non-zero digit are significant, but means zeros after non-zero digits. So these 3 zeros are after non-zero. These can be significant only if they are on the right side of decimal point. So if I write 4000, these zeros are not on the right side because decimal is here. So these will not be significant. But if I write this one, these 2 zeros become significant because these are after decimal. This is significant. And now by applying this rule, zeros between two non-zeros digits are significant. So this is significant. These two became significant. And this zero is in between two significant figures. It means this will also become significant, even if this is left side of the decimal point. So don't think that if I place decimal here, only these two will become significant. These two will become significant, but now because you have this zero between two significant figures, this also becomes significant. Total 4 significant figures will be there. Exact numbers have infinite number of significant figures. For example, if I say 100x, I can't say 99.9x. It will always be 100. So if it is 100, the decimal zero will go to infinity. It will not have any fraction. So that's why infinite number of significant figures, because all these zeros are after decimal, and after decimal, the zeros are significant. Infinite number of significant figures. So example, for example, for non-zero digits, for example, I said 0.25 ml, so it will have only two significant figures. This is on the leftmost part. There is no significant digit here, so that's why it will not consider. Zeros preceding to first non-zero. Now, zeros preceding to first non-zero digits are not significant. First non-zero digit is this one, preceding to this one. This is actually the previous one, same thing, will not be considered as significant figures. Zeros between two non-zero digits are always significant. So this is something I have already told you. If I write 2.005, all four are significant. Even if I have written 2005, all four are significant. Zeros at the end or right of a number are significant. This is the one which I said that the zeros will be significant if these are after the decimal. Yeah, that part is written here. So 0.200, these two will become significant. If I write 200, it has only one significant. If I write 0.200, it has three significant figures. If I
So
write
if you write
2.00, yes,
so if you write 200.0, then all of them will be significant. Right?
yes, four significant figures, because this has become significant. This is after decimal. This is significant. These two zeros in between two significant figures will be significant. Four significant figures. Exact numbers, as I said, 100x, these will have infinite number of significant figures.
Sir,
Yes,
sir, 4000 will be having one significant figures.
yes, 4000 will have one, because these zeros will not be considered as significant, because these are not after decimal, rather these are before decimal.
Yes, sir. Or sir, if it would be 4.000, then it will have four significant figures.
Four significant figures. Yes, correct.
Yes.
Sir,
Yes.
so can you please tell the rules of addition and subtraction of significant figures?
I am coming to that.
Okay.
When numbers are written in scientific notation, the number of digits between 1 and 10 give the number of significant figures. So if I write it in scientific notation, only this part will decide the significant figures. Only this part, not the exponent part. Okay. So here you have three significant figures. Here you have four significant figures. Exponent part is not considered to calculate the significant figure. So suppose I ask you calculate the number of significant figures in the following. Tell me how many significant figures are there?
Sir, 4.
4.
Mhm. Who said Laksh? You said 4?
Yes, sir.
Sir, 2, sir. 2.
Sir, 2.
Yes, sir. 2.
Yes, sir. 2.
Yeah, good. There will be 2 only because the first rule says that if there is no non-zero digit before any zeros, means these are leftmost zeros, these will not be considered. Okay, and that's why I have kept this question here, because this is the confusion. If you read the rule says that if zeros are after decimal, they will become significant. I'm going back to show you the rule. That's why you are confused. Okay, the rule says zeros at the end or right of the number are significant only if they are on the right side of decimal point. So this does not say that they have to be after non-zero digit also, and that is the problem there. This is the rule written in NCERT. So you need to know that there is hidden thing here which you need to apply, which is not written in rules. That even though we say that zeros after decimal will become significant, provided they are after non-zero digit also. So means if it is something 3.0025, then yes, these will become significant. Or if it is just 3.00, then these will become significant. But if there is no digit before zeros, these will not become significant even if they are after decimal. Did you get what is hidden there? And you have to remember.
sir.
Yes, sir.
Yes, sir.
And this is the question where most of the students make mistakes. There is only 2. 208. How many significant
3.
figures?
Sir. 3.
Sir,
Two.
3. Good. 3,
Two.
3, 3. Because these are significant and zeros between significant figures are significant. We know the rule that zeros between 2 significant digits are significant. That's why this is.
So,
Yes.
so why not infinite?
Right. If it is not written that it is egg or ball or something, you will consider it that it can be divided into pieces.
Okay, sir.
Okay. So if it would have been written 208 pence, so you won't say I can have 200.5 pence. It doesn't make any sense. Then it will be infinite.
Okay, sir.
Sir, could you tell once more why there are only 2 significant figures in the first question?
In the first one, okay. First one. Zeros before non-zero digits or before decimal are not significant.
Okay, sir.
Zeros before non-zero digit 2 before, these are not significant. Or before decimal 0.002, this is not significant. Okay? But the hidden rule I told you, what is not written, and that's why I included that question. Hidden rule is not here, rather in the fourth part, this one. It says zeros after non-zero digit are significant only if they are on the right side of the decimal point. So if you combine these two, you need to understand, if you combine these two, that is the zeros after non-zero digit can become significant only, means 2.00 if they are on the right side of decimal point. I'm just highlighting 2 things. We are talking about zeros. These should be after non-zero. So suppose if I say 0.00 condition not met, because it is written zeros after non-zero, means I should have some non-zero here, and then after. And then on the right side of decimal point, yes, these are on the right side of decimal point, then these will become significant. But if I have 0 here, this condition is not met after non-zero. These are not after non-zero. These zeros
Okay, sir,
are
got it.
after 0.
Yes, sir, got it.
So these will not considered as significant.
Significant.
So that's why in this case, we have not considered these zeros as significant. Not significant, not significant, not significant. Four significant figures here because these zeros will be
Yes, sir.
considered as significant. These are between two non-zero digits. Now tell me how many significant figures here?
Three, three,
Sir,
three.
Good.
Three.
These zeros will not be significant because these are not after decimal. So three only, and you will not consider infinite because it is not given whether it is any object. 500.0, how many significant figures?
Four.
4.
Good. 4 because now this 0 is after decimal and it is after non-zero digit. So that's why it became significant. Non-zero is anyway significant. These two zeros between two significant became significant. So total 4. 2.0034.
Five.
Five.
5.
Five.
These are significant. These are in between. These will become significant. 5. Good. Now, in such questions where it is multiplication, etc., okay, or division, etc., the rules are, first I am telling you the rules and then I'll come back to this question. For addition and subtraction, the answer is rounded off to match the same number of decimal places as the quantity with the least number of decimal places. So if I am adding say 5.0 plus 3.29 plus 15.5 or 453. If I am adding this, I add 3.29 and 5.0. 3, 4, 7, 5.0, 3, like this. So the answer will have as many decimal places as one having by the minimum one. So minimum decimal places after decimal is the 1. Here you have 1, here you have 2 decimal places, here you have 3. So in the answer you will have decimal places only 1. It means the answer here will be 23.7 only, not 23.743. Is the rule clear? When you are adding,
Yes, sir.
the result will have as many decimal places as the quantity with the least number of decimal places. However, the rule for multiplication and division is different. For multiplication and division, the result will have the minimum number of significant figures as there are in any one. Suppose I have 2.3 multiplied by 5.23. Suppose. Then in the result, there will be only two significant figures because here we have two significant figures. Two significant figures, three significant figures. Answer will have two significant figures, the minimum. So in multiplication and division, it will be on the basis of minimum significant figures. In addition and subtraction, the result will be on the basis of minimum number of decimal digits. You need to memorize this, okay? So minimum number of least number of decimal places, addition and subtraction, and least number of significant figures, multiplication and division.
Sir,
Yes.
sir, can you please tell once again for addition and subtraction?
Addition and subtraction, for addition or subtraction, result will have minimum number of decimal places. So suppose you have 5.3 plus 103.2549 plus 3.01. So the minimum decimal place is 1. So result will have some digits, okay, and dot n only will be of this form. It will have only one digit after decimal because any of these 3 or 4, whatever you are adding, the one which has the minimum number of decimal places, that will decide the result having the same number of decimal places. Is that clear?
Yes, sir, I got it.
So minimum number of decimal places 1. The result will have decimal place only 1. So you will round off the result. Multiplication division, minimum number of significant figures. Now I'm coming back to this question. Now in such questions, I'm not saying that this 5 is something you will consider as infinite significant figures or you will consider as one significant figure. In calculations, if you have exact numbers, these are not included in calculation of significant figures. I am repeating it. I am not saying whether 5 will decide as per the infinite significant figure or just one significant figure. I am saying it will not be considered at all if it is exact number in calculation of significant figures in the result. So in the result, whatever you get, because it is multiplication, and for multiplication it will be minimum number of significant figures, and because there is only one number apart from exact number, there will be 4 significant figures. This will only decide how many significant figures will be there in the answer. Is that clear or not?
Yes, sir.
I am giving you another example.
Yes.
If you have 3.1 multiplied by 39 into 6, then this 6 will not decide the significant figures in the result. You will consider only these two, and because it is multiplication, you will consider the minimum number of significant
Two
figures. So you will
There
have
are two significant
two
figures.
significant figures in the answer.
2 significant figures.
Okay. So this is where students make mistakes. Many students lose marks because they consider exact numbers in significant figure calculation. You will ignore it. This is something which you need to remember so that you don't make mistake. It is not a rule, right? It is something that you don't make mistake. After the decimal point in the result, there cannot be more digits than any of the original numbers. Means it cannot be possible that you can have 1.3 into 2.95 into 143.2396. Suppose that. Okay. Then the result can have maximum 4 decimal places. We are talking about multiplication. Okay. In multiplication, although here it is very easy because it has only 2. Suppose I say it is a 243.2396. This is 101.1342, like this. When you multiply this, obviously the result will have multiple digits after the decimal. Are you getting it what I am saying?
Yes, sir.
Right? When you multiply so many decimal places, you will have 12. Okay. You will have 12 decimal places because you will have to consider 4 decimal places. But answer cannot have more digits after decimal than any original number. So maximum decimal digits are 4. It means your answer can have only 4 decimal digits, not more than that. So you need to round off even in multiplication and division. Although this rule is not written, but this will be considered. Easy one, but you need to remember. Now rules for rounding off. Rules for rounding off almost same what you have done in previous classes. Only the difference is when the digit to be removed is exactly 5. If the digit to be removed is more than 5, then you add normally, or when it is less than 5, then you remove it as it is. But if the rightmost digit to be removed is 5, then preceding number is not changed if it is an even number. It is increased by 1 if it is odd number. How you will remember it? You will not remember it like this. You will remember it that if you have to say it is 3, 5 and 7.82, you will just remember if this is exactly 5 and you have to remove, the previous digit will always be even. You will remember the rule when we remove 5, then previous digit will always be even. Just remember. If it is not even, add 1. So it means for this one, first one, it will be 7.8. 3 is not even, make it even. Add 1. For this one, 7.82, 2 is even, leave it as it is. It is already even. Otherwise, the rule is simple. Greater than 5, add 1. Less than 5, remove it. Don't do anything. Yes, Samad, your answer is correct. So in other words, if rightmost digit is 5, then preceding number will always be even. Laws of chemical combination. Most of the laws are easy except the law of multiple proportion where you face problem. I have not included the law of reciprocal proportion. That is specifically for JEE and NEET. This is CBSE I am covering at the moment. So law of conservation of mass means before reaction, after reaction, the mass is same. Now tell me the answer quickly. For this question, I need to check whether you understand this rule clearly or not. It should require around 20 seconds, maximum 30 seconds. Yash Bedi, correct. Arjun Singh, correct. Kartike, Kavish, Shashwat, correct. This question is actually about conservation of mass. You have the reaction, sodium bicarbonate reacts with acetic acid, and the residue is found to weigh 18 grams. Now, when you talk about the residue is this one. Carbon dioxide escapes out, is released. So residue is 18 gram, and this one is 6.3 gram. This was 15.0 gram. It means before reaction, after reaction, it has to be same. So 6.3 plus 15.0 will give you 21.3. This is 18.0. It means this will be x will be 21.3 minus 18, 3.3. Law of definite proportion or constant composition. So it can appear with any name. Definite proportion or constant composition means the amount of the elements in a compound is always same. So if I say Na2CO3, there in 1 mole there will always be 2 into 23, that is 46 grams. I have 1 mole of sodium. There will always be 12 grams of carbon. There will always be 3 into 16, 48 grams of oxygen. That's what it says. Whether we have prepared in laboratory, whether we have got it naturally from somewhere. Okay. Then law of multiple proportion, which is slightly confusing if you don't understand. Otherwise, it is easy. And most of the questions normally appear from here. Multiple proportion, very important. Law of multiple proportion says that if you have two elements, and they can combine in different ratios to form two different compounds. Then if we keep the amount of one as fixed, so say if I fix A, then amount of B will be in simple whole ratio. So it can be 2B, it can be 3B. Okay. So here ratio is 1:2. Here ratio is 2:3. So I'm keeping A fixed. So if I keep the amount of one element as fixed, then the masses of the other element will be in simple whole ratio. Memorize this definition. This definition is asked quite a few times. So memorize. Next question, carbon and oxygen are known to form two compounds. The carbon content in one of these compounds is 42.9%, while in the other one it is 27.3%. Show that the data are in the agreement with the law of multiple proportion. Means we have to fix the amount of one. Okay. So here the carbon content in one of the carbon is this one. So carbon, oxygen. So in first case, carbon is 42.9%. In second case, it is 27.3%. It means oxygen here is 100 minus 42.9.
57.1.
That is 57.1. Here 100 minus 27.3. 100 minus 27,
72 point.
72 point. So it means if I have, percentage wise, obviously, I fix the amount of 1 gram. So if I have 42.9 gram of this one, oxygen will be 57.1 gram out of 100. Out of 100 gram, if I have 27.3 grams of carbon, 72.3 grams will be oxygen. Okay. So how can I fix the amount of 1? Fix it to 1 gram. And you can apply unitary method. If 42.9 gram carbon corresponds to 57.1, 1 gram will correspond to 57.1 divided by 42.9 gram. Similarly, unitary method, 27.3 gram corresponds to 72.7 grams of oxygen. 1 gram of carbon will correspond to 72.7 divided by 27.3. So according to law of multiple proportions, these two should be in simple whole ratio. Try to find out, solve, and see whether these are actually in fixed ratio or not, because we have fixed mass of carbon. Yes, Arjun, correct. You solve 57.1 divided by 42.9. You get 1.33. And here you will get 2.66 grams. 72.7 divided by 27.3. It means if you divide both of these by 1.33, it will be 1:2 ratio, which is simple whole ratio. Any confusion, let me know. Law of multiple proportion always fix the amount, usually in such questions 1 gram, and get corresponding amount of the other element, whose ratio you have to find, mass ratio. So those masses should be in simple whole ratio. Any confusion here?
Sir, can you please tell why did you divide 57.1 upon 42.9 in the first and second cases?
Okay. Because as per the rule, I have to fix the amount of one component, any one component, okay, combined with the fixed mass of the other element. So I have fixed the amount of carbon. What I know that 42.9 grams of carbon, and I have compound, okay, COCXOY, and 52.1 gram oxygen is there. So this is what I know. It is given. Okay, this much 42.9 carbon, 52.1 gram oxygen. But I have to fix the amount of 1. So say I fixed it to 1 gram. Then if it is 1 gram, then how much oxygen it will correspond to? So I have applied unitary method. 52.9 gram carbon corresponds to 52.1 gram of oxygen. So 1 will correspond to unitary method. This 52.1 divided by this 42.9. This is similar to, for example, if you say 5 pence cost 50 rupees, so 1 pen will cost 50 by 5. Is that clear?
Yes.
So you have to fix, usually you fix as 1 gram. Okay. Otherwise, there is other way also. You can fix the amount, say 23 only. Say I will fix it as 23 grams. So you don't need to change anything in that case here. You will say I fix the amount as 27.3. It has 72.7 grams. Here you calculate instead of 1, you calculate in 27.3. So you say 42.9 gram corresponds to 57.1. Hence 1 gram will correspond to 57.1 divided by 42.9. Hence 27.3 gram will correspond to 57.1 divided by 42.9 into 23.7. So now you have fixed both masses as masses of carbon as 23.7, and you will again get the similar ratio 1:2. So whatever you get here and whatever you get here, these will be in 1:2 ratio. This will be 1, this will be 2. Is there any confusion? Let me know.
No, sir.
No, sir.
Then Gay-Lussac's law of gaseous volume. This is the very simple one. It says that if gases combine or are produced, they do so in their simple ratio by volume. Means at same temperature and pressure. Means if you have 2H2 gas plus O2 gas, you will get 2H2O gases. Means you have here two volumes. Here you have one volume and you get two volumes. It means the ratio is 2:1:2, which is simple whole ratio. That's what Gay-Lussac's law says. Similarly, if you have N2 plus 3H2 gases, they give you 2NH3 gas, ammonia gas. It is one volume, three volume, two volume. So 1:3:2. Again, simple whole ratio, nothing decimal like that. That is Gay-Lussac's law of gaseous volume. Then Avogadro law is basically the definition of mole. It says equal volumes of gases at the same temperature and pressure should contain equal number of molecules, which we say that 1 mole is equal to 22.4 liters at STP. Whatever gas we are talking about, irrespective of the gas, we are talking about its volume is constant if we are not changing the temperature and pressure. Equal volumes of gases at same temperature and pressure should contain equal number of molecules. Why? Because if we are talking about at STP 22.4 liters will have 6.022 into 10 power 23 particles. If it is molecules, molecule. So if you have another gas at the same temperature and pressure, whether it is O2, whether it is N2, same volume will always have same number of molecules. Half of it will have half the number of molecules. The only condition is temperature and pressure should not change. Dalton's atomic theory, this is something which is not very important from 11th perspective, but still if your teacher wants to, tease you, then might these questions can be asked. So Dalton's atomic theory, matter consists of individual atoms only, nothing else. All the atoms of a given element have identical properties. So because atoms are same of a given element, so if it is aluminium, aluminium, aluminium only everywhere, It will have similar properties, obviously, that is common sense. Atoms of different elements differ in mass. Yes, their atomic mass is different, that's why their mass is different. Uh, Samarth, I think you were asking for the previous part, not this one. Yeah. Compounds are formed when atoms of different elements combine in a fixed ratio, which is something you already know, that Al2O3, for example, two aluminium atoms and three oxygen atoms combined. So it is 2:3 ratio, fixed ratio, always fixed ratio for this compound. Carbon dioxide, 1:2, fixed ratio always. So for a compound, this ratio will always be fixed. Chemical reactions involve reorganization of atoms. Atoms do not change. Atoms do not change. This is just reorganization of atoms. Means, for example, if I have simple, again same, we have 4 hydrogen, 4 oxygen on left hand side, we have same on right hand side. It is just reorganization. Their placement and combination is different. Atoms are neither created nor destroyed. We can't create atoms, we can't destroy atoms. So Dalton's theory could explain the laws of chemical combination, but not all, but mostly. Now, atomic mass and molecular mass. The students remain confused, however, this is 9th standard I am covering here. One atomic mass unit is defined as mass exactly equal to 1/12 mass of one carbon atom. Now, why we needed atomic mass? We needed atomic mass because we can't use grams there. Gram is much larger unit as compared to the atomic mass unit. So suppose I'm giving you an example. Suppose you have to measure the length of a table. Now, will you use kilometers here? Obviously, it will be very the odd if you use kilometers here, because the good way is to use either meter or centimeter, a smaller unit. So what you did, you used a smaller unit. Inside the atom, if inside the atom I have to measure some distances, or if I have to measure the mass here, which is so small that I can't use even gram. So if I have to, for example, weigh uh, one one apple, yeah. So if I have to weigh one apple, I will not be using ton, metric ton, etc. I will use most probably grams, even not kilograms. So I need a smaller unit. So if I want to weigh proton, neutron, electron, I can't use gram. Gram is much larger unit. So that's why atomic mass unit was defined, and it was given exactly same mass as 1/12 of the mass of one carbon atom. So one carbon atom 12, it has some mass. When we divided this by 12, it became 1 unit. We consider that as 1 unit. With respect to that one, we calculate the masses. So suppose we have this much mass of neutron, suppose, and this much is equivalent to 1 U. So we will say 1 U, 2 U, 3 U, 4, 5, 6, whatever. Okay? These many U's are there. It can accommodate these many units. So it is equal to those many units. That's what we do. So 1 unit is actually equal to 1.66056 into 10 power minus 24. Those who are preparing for JEE and NEET should memorize this value. You might need to use this value for some tricks. Okay, tricky questions. If you know this value already, you can get answer very quickly. So memorize this value. 1 unit is actually 1.66056 into 10 power minus 24 grams. So the atomic mass or atomic weight of an element is the average relative mass. So why we call it average mass? Because uh, the there are isotopes of them. So average means we need to consider all the isotopes also. Okay. So if we talk about molecular mass is sum of all atomic masses in that molecule. If it is ionic compound, say NaCl, then instead of molecular mass, we normally also call it as formula mass. Otherwise, both are same thing. Formula mass, molecular mass, both are sum of atomic masses, nothing else. Okay. So some here, for example, atomic mass 23, sodium 35.5, 58.5 U will be formula mass of sodium chloride, but we call it molecular mass also. Now, average atomic mass. Average atomic masses, as I said, there are multiple isotopes present. So we consider the atomic mass for all isotopes. So it is given by, now I don't really remember whether this formula is there in NCERT or not, but you need to remember the questions are asked. It is sigma, and I hope you know by mathematics that what sigma means. Sigma is sum of all these values for all values of I from 0 to n. So for example, if you have these values given, you have carbon 12, carbon 13, carbon 14, 3 isotopes of carbon. And their relative abundance means how much percentage is available in universe or on earth. 98.892 is carbon 12, 1.108% is carbon 13, 2 into 10 power minus 10 is carbon 14. And their atomic mass is carbon 12 atomic mass is 12, carbon 13 atomic mass is 13.00335, carbon 14 is 14.00317. So what we will do to calculate the average atomic mass, we will calculate this atomic mass, this atomic mass, this atomic mass, and we will add average.
So,
Yes.
so can you please tell what was relative abundance once again?
Relative abundance is out of 100%, what is their percentage? If you have 100%, okay, these total will be 100%, out of which 98.892. 12, carbon 13, carbon 14. So how you will calculate it? You will use percentages as fractions. So here, remember, this one is atomic mass 12, for example. So how I will calculate atomic mass, average atomic mass here? I will say it is equal to, for this one, 12, M1 is 12, atomic mass 12. And abundance is 98.892. I will use it as fraction. I will say 98.892 divided by 100. This is the key point you need to remember. Otherwise, you will not get the correct value. You can't use percentage. Percentages have to be converted to fractions before you use them. You know that in mathematics. Percentages are not directly calculated. They are converted to fractions. Then second one, 13.00335 into its abundance 1.108% divided by 100. Now it became fraction. Then again M3 is 14.00317 and its abundance 2 into 10 to the power minus 10 divided by 100. Whatever value you get, that is the average atomic mass. Although you will not get such complex calculation there, but you will get simple. You might get questions based on simple calculation where you have to calculate average atomic mass. Okay. So for example, in case of chlorine, it is normally asked for chlorine because chlorine also has two isotopes, chlorine 35 and chlorine 37. So their abundance, according to their abundance, you will use just two, M1 A1 plus M2 A2. So their abundances will be given, their atomic masses, individual atomic masses will be given. Just multiply and add.